How's everybody doing? Good? All right. So, what are we doing today? Let's talk about web fonts, right? Are you guys excited? Yeah, let's get it going. So, it's a brief history of that one time that used web fonts, right? I'm sure it went great. As Vitaly said, I'm Zach Leet. I'm ZachLeet.com. Zach Leatherman's my real name. It's just abbreviated. And also...
Are you going to introduce me?
Steve, leave me alone. We talked about this. Steve, we agreed you weren't going to jump into my presentation. I don't care how smart you are. This isn't a physics conference, okay? We're talking about web fonts today. I'm going to have to go ahead and quit you. Nope. Oh, well, whatever. We'll just move on. So in the beginning, 4.5 billion years ago...
Pardon me.
Yes, Steve. What do you want?
I think you mean 1995.
Fine. In 1995, we only had a couple of fonts available to us in our web browsers, right? The fonts that were by default installed on the machine. It was very limiting. And we used them with this lovely font tag. Hey, who's used a font tag in here before? Oh, well, that's way more than, that's kind of depressing. But just for reference, here's a site that I built about that same time. It's about volcanoes. It's pretty good. It's rated 5 stars. It's got that little image there, yeah. So yeah, it was pretty good, right?
No comment.
Fine, Steve. But we wanted more from our typography, right? So fast forward to today. Hey. We can now use font face. It's amazing. Yay, clap for font face. No, don't clap for font face. It's good, but it's bad. And I'll tell you why. It's very simple. You just use a font family. You put your source URLs, your different font formats in there, comma separated. Usher in the age of font face. This is a great time. And it's very popular now. So according to HTTP Archive, 56% of websites actually use font face. And the payload for fonts is growing on our sites. Right now it's 105 kilobyte. In 2012 it was only 13 kilobytes. So that's a 700% increase in only 3 years. A huge jump. But when it comes to the actual transfer size of assets on our page, web fonts is actually a small slice of the pie. And you'll notice I didn't use a pie chart here because pie charts are horrible. But when it comes to web fonts, it's very small compared to images and JavaScript on the page. And you might have heard this said before. Oh, if you're worried about the amount of JavaScript that you're transferring on your page, you can just remove an image, right? It's the same thing. No, that's a misnomer. Not all requests are created equal. I think Patrick said that yesterday. It's all about perceived performance. So, images, even though they take up the majority of our page weight on average, also have a very lightweight impact on perceived performance. So they load in a very non-blocking way. They just kind of chunk in when you use PNG, WebP, and baseline JPEGs. And when it comes to CSS, CSS blocks rendering altogether. And that's kind of why we've now started to divide our CSS into critical and non-critical. And this is kind of how JavaScript loads by default. And we can improve this with the defer attribute and the async attribute, and using the preparser to sort of fetch it early. But this is how web fonts load. So when it starts the download, it makes all of the fallback text invisible in most web browsers. So it's a non-trivial performance impact. So if you've been micro-benchmarking your JavaScript for loops, maybe it's time to look at your font loading strategy. But we're kind of getting ahead of ourselves a little bit. So let's go back to our font face block. You'll notice that the stack in our source property includes 2 different formats, a WAF2 format and a WAF format. Now using both of these formats together, the browser will just use the first one it can understand, gives us a great mixture of browser support and performance. Now Google Fonts did a study, or Google did a study on their Google font property and found on average that WAF2 is about 30% smaller than WAF. But the browser support isn't very good for WAF2 yet. So we also have to add in the WAF format. But if you'll note, there's a large portion of Android that doesn't yet support WAF even. And 37.6% of Android users don't have support for any WAF formats.
What were you saying about pie charts earlier?
Yes, this is a pie chart. Okay. So to solve that problem, to serve web fonts to antique Android, as I like to call it, you can also include an explicit OpenType or TrueType format as a third option. I don't really include that in the examples here because as time moves on, that will sort of fade away. But I've included it here, but yeah, I won't include it for the rest of the examples. So we'll take our font face block, dump it into some HTML. This is about the bare minimum HTML page you can have, just a style element and a doc type. But when we look at that in our web browser, bring up the dev tools and look at the network inspector, and you can see that this one's filtered to just show font requests. 0 out of the 1 requests that are made on this page are for fonts. The font isn't actually requested. There's no download. No download took place. And if you're familiar with English, you know that 1 is not a plural number. So I don't know why they've included 1 request there. So we can go ahead and just go and reset the counter and say it's been 0 days since the last pluralization errors.
You do realize that 0 is plural, right?
Yes, 0 is plural, so reset it again. So if it's not actually used in the content of our page, it's not downloaded. That's a very important distinction to make. So to get the font to actually download the file, you have to add an element to our document that uses that font face. So if we add a simple paragraph tag to our page, that will trigger a download. And in WebKit and Blink, that element has to be non-empty. It has to have content in it. So here's a browser compatibility table for that. On the left, you can kind of see the browsers that will download with non-empty elements attached to the page. And on the right are empty elements, so Firefox, IE9, and Edge. But we don't have to apply font family to an entire element, right? We don't have to apply our font face to an entire element. We can we can restrict it to specific characters with the Unicode range property. So for example, let's say I created a font that contained only an ampersand character. I wanted a fancy ampersand that I custom made myself and I wanted to use on my page. So it's very similar to what we were doing before, but we've added this Unicode range descriptor to the bottom that contains the glyph that is mapped to our ampersand character. So this is known as a code point. So you put a code point range in there, and that tells the browser what characters are contained in this file, what characters do we want to render. And this is how it will render on the page. So our ampersand on the right, you can see, is using my new font face that I've designed specifically for ampersands. And then on the left, it just renders with the fallback font, even though there's just one font family applied to this entire thing. And even if I had more glyphs inside of that ampersand font, most browsers will only apply the characters that you've declared in your Unicode range. So here's a browser support table for Unicode range. It's actually pretty well supported, but there is a problem here, right? Because Firefox doesn't support Unicode range at all. It's behind a flag, so it's not available by default to web users using Firefox. So that's why we need to subset our fonts to only contain the glyphs that we want to render. Because Firefox doesn't support Unicode range, it will render the entire element using our font face. And even better, Blink has a smart download behavior. So if the content that I'm using in the element does not match Unicode range, it won't download the font. So, kind of confusing so far. So I made this nice little checklist to determine when a font gets downloaded and when it doesn't. So there has to be an exact match on the font family. It has to be used in an element on the document, attached to the document. In blank, it has to have content. And that content needs to be within the Unicode range that we've declared, if a Unicode range exists on our font face block. But there are actually two more criteria that the font face matching algorithm uses: font weight and font style. And also font stretch, but nobody really uses that anymore. Maybe they will someday, I don't know. But these don't require an exact match. So you get some really weird rendering behavior if you don't have an exact match for these. So if everything matches up correctly, it's great, right? We have our font weight 400 in our font face block. Our tag style uses font weight 400, non-italic, perfect. Everything renders correctly. But what happens when the font weight doesn't match exactly? So if I only have one font face block on my page, and my element style on the right wants a font weight of 100, but 600 is the only thing that's available, it will render that as bold. It will use what's available. So you're expecting a lighter weight, right? But we only have a heavier weight available to us. And the same thing for italic. If I wanted normal, if I put a normal on my element style, and italic was the only thing that was available to me, it would use italic. It would render as italic. And font weight gets kind of even trickier. So font weights are actually divided into a lower spectrum and a higher spectrum. So anything 500 and below is considered normal or lighter weights, and 600 and above is bolder weights. When you cross over from a lower weight to a higher weight, so our font face block is a lighter weight, what we have available to us on the page is a lighter weight, but we want a heavier weight to be rendered. So for example, 500 is what we have available, but we want 600. The browser will actually synthesize a new version of the font that it has. So we have 500. It will actually add extra weight onto the 500 version to kind of try to create a faux bold version of the font. So on the right column, you'll see this faux bolding situation. And this clipped content here shows the native font weight 600. So you can see that the thing that the browser has synthesized, the thing that the browser has created, does not even match what it should be rendered as. So if you're really into typefaces, this faux bolding situation is very bad, it's very ugly, it's very hard to look at. And it does the same thing for italics. So you can kind of see how italic should render in this typeface on the left, and this is the faux italic on the right. And you'll often see this behavior on your websites when you only load the normal font style, normal font weight block on your page. So you only have a single font face. But you use it with elements that have default style associated with them. So for example, strong is often styled by default in web browsers as being bold. Emphasis is often default styled using italic. So there is a font synthesis property that we can use to control this behavior, which is great, but browser support is not good. It's only supported in Firefox. And this compatibility table is actually from State of Web Type, which is a great website that sort of documents different font features that are available in different browsers. It's made by Braunstein. He speaks at SmashingConf. Not this one. So let's try and put this into practice and look at a real-world example. So I went out to Instagram.com, parsed their CSS, looked through it, and found that they actually had 6 different font face blocks on their page. This is probably more than I would recommend. It's quite a few, but they're all Proxima Nova, different weights and styles. But if we look at that in the network inspector, we see that only 3 of them got downloaded. So 3 out of the 6, that's not bad. But if we actually look at the rendered version of the page, we can see on the top right that the login button looks to be bold, the title looks bold, The normal paragraph content is Roman, but I don't see the third version of the typeface. You can kind of see here that there's an italic version that's getting loaded. So, you might see where I'm going with this. There's a nice little home icon they have here in the top right. It's not a font icon. It's a background image on an element that they have in a button. Can anybody guess what element they're using here? Yeah. So the only reason that that third font face was loading on the page is because they were using an I element to mark up that icon. And so if they want to save about 13 kilobyte by not making that font face request on every page, all they'd have to do is reset that element to have font style normal. Very simple fix. So we've learned a lot about how to trigger a font download. But more interestingly, at least to our perceived performance, is how do the fonts behave while they're downloading? So for this example, I used a lovely recruiter email that I received for my lorem ipsum text. And you can see that the local font up top is just a locally installed serif font, probably Times New Roman or something. And then the bottom is the web font. So while the font's loading, invisible, right? No fallbacks. This is known as the flash of invisible text. And you might have also heard the term FOIT, although I don't like to pronounce that out loud. So on Facebook.com, you can see this problem all over the web, right? But on Facebook.com, if you look at it in this web page test film strip, you can kind of see that Facebook is missing some content here, right? Looks like something's missing. The text is there, but it's loading a web font for that. So for 200 milliseconds on a very good cable internet connection, that text was unreadable to the user. And Harry Shum of Microsoft has this great quote. He said, he did a study and found out that people will visit a website less often if it's slower than your competitor by more than 250 milliseconds. So even a small change can make a huge difference. And Facebook spent an additional 200 milliseconds just for that web font to load. But that was on a cable connection, a very good, stable internet connection. But what if the network connections aren't ideal? So let's go back to our Instagram example, this time on 3G. So remember how it loaded 3 different fonts? Here we had to wait 1.3 seconds for the Roman font to load, and an additional 300 milliseconds for the bold font. So that's 1.6 seconds of waiting. The text is available to the page. If a fallback was shown, the user could have read it, but this native browser behavior, the default browser behavior of hiding the fallbacks, is bad for perceived performance. So Matt Scholl has another quote. He said, if a page hasn't loaded within 3 seconds, up to 40% of the users will actually abandon the site. So does Facebook really want to spend almost 50% of that time hiding a fallback font? I would say no. So here's another example, apple.com on 3G on an iPhone. You can see that initial render starts at 8 seconds, which is not good. But 5 seconds after initial render, the hero image loads. And then another 3 seconds after that, their web font loads. So you might notice that there's a little text down here. That's actually an image. So the images are loading before the text is readable, which creates a very weird situation. And this is the last stage in the film strip, right? Nothing loaded after this. It's not good. And Patrick also mentioned this yesterday. He said font requests are a single point of failure in Safari. Because there is no timeout for these, and we know how unreliable networks can be, if the font request doesn't come back, if it isn't returned, the text never renders. Nothing, it's just blank. The screen is blank. So you might think, oh, the user can just hit the stop button, right? It's loading, it looks like it's loading. Nothing has returned. What, does the stop button do anything? No, the stop button does nothing. So the user's only recourse in this situation is to reload the entire page, which is a very, very bad experience. So one thing that browsers have started to do to kind of combat this behavior is they've added a default timeout inside of their font loader. So Firefox and Opera and Chrome have a 3-second timeout. So if the font hasn't loaded within 3 seconds, it will show a fallback font. And then when the web font loads, it will swap that in. This is known as the flash of unstyled text. And again, I don't like pronouncing this, but it's FOUT. FOUT. Yeah. So is 3 seconds a good timeout? Is 3 seconds a good timeout to show our fallback text? So worldwide, every 3 seconds, 13 children are born. I'm a new father, so here's mine. Pander to the audience.
No one wants to see your kid.
Okay, yeah, that's harsh, but okay. 10.2 million emails are sent every 3 seconds. And if we remember Matt Schultz's tweet, 40% of users have abandoned our website. So 3 seconds, not a good timeout. That's a very, very long time for someone to wait for text to be readable. Now, I do have a warning. If you're feeling squeamish, you may want to look away because the next slide has some graphic imagery. Might be a little disturbing. I'll give you. Is everyone okay? All right. Internet Explorer does a great job at this. They use, I'll go back. You can take a picture. Go. Internet Explorer does a great job at this. They show the fallback font right from the beginning. 0-second timeout. So the text is readable immediately. When the web font loads, they swap it in. So before we go on how to fix this problem, I want to talk about a few anti-patterns that I've kind of noticed crop up. And I think they kind of reveal how misunderstood font loading behavior is. So one approach that I've seen relies on CSS onload, a very popular web development blog that I won't name posted an article with this example. They were like, use this for your font loading. So they have a link element here. They load the font CSS, and then when the CSS is loaded successfully, they add a class which then applies their font family. Now, ignoring the fact that link onload doesn't actually work in antique Android, this technique does not work well for font loading. So the CSS blocks for the same reasons that we talked about earlier, but the font requests also block, right? Because onload is triggered here. And we have this default browser behavior danger zone that we're trying to avoid that takes place over there. So the repaint is happening much too early. We want the repaint to happen after the fonts have loaded successfully, not when the CSS has loaded. So don't think that when the font face block is parsed on your page, that's when the download occurs. We already know that font face downloads only happen after the browser knows that content is using it on the page. Another one that we actually used at Filament Group for a while, asynchronous CSS with data URIs. And you might have seen a few articles around the web about this with local storage, using local storage. It's a very similar approach. And we actually have a tool that's called Load CSS, which is great for loading asynchronous CSS when you have divided it into critical and non-critical. But if you're using it for font loading, it's a little bit different. And my colleague Scott Gell does a great job maintaining this project. He keeps it updated, he keeps it well maintained. And whenever he releases a new version of it, I say to him, "Great, Scott." Don't clap for that. So this is what it looks like in our font face blocks. This is a completely separate asynchronously loaded CSS file that we've just dumped our data URIs into it. And it worked pretty well. It doesn't block until you get to the end when it starts to parse the data URIs. We saw a little bit a little sliver of this default browser behavior danger zone where it would actually repaint with the default browser behavior. And this is what it kind of looked like in our web page test film strip. You can see that on the left, the fallback fonts have rendered successfully. And then we had a 200 millisecond invisible text situation while the web fonts, I think while the data URIs were parsing. So that didn't work quite as well as we wanted. Another, in my opinion, the worst one that I've seen is on Alibaba.com. I don't know if you guys are familiar with that site. They actually inline their data URIs into their main CSS. So this blocks the entire page render instead of just the fallback text, which is not good. They have one big giant 50 kilobyte CSS request that they load in a blocking manner, and half of that CSS is font data URIs. So yeah, not good. And when you use data URIs, you kind of opt out of that smart downloading behavior that we talked about. And you opt out of the auto format selection. So for example, WAF2 versus WAF. You usually have to predetermine what font format the browser can use before you download which one you want. But there are some anti-patterns that aren't just performance problems, right? They don't just affect the perceived performance of our pages. So Slate.com had this excellent article earlier this year about the US presidential campaign. Slate.com is a news website that prides itself on journalistic integrity, accuracy of headlines, and they've used a web font here for their title. But there's kind of something interesting happening with some white space there. I don't know if you've noticed that. So is Mitt Romney or is Mitt Romney not running for president? He's actually not running for president. And you can kind of see what happened there because they used a different web font for their normal title and then another web font for their italic title. They had different flash of invisible text. Each font file that you load has its own separate flash of invisible text or default browser behavior associated with that. So this is good, right? No, not good. So, a little controversial. I also think that using font icons is an anti-pattern. So Chris kind of touched on this yesterday. SVG is a great alternative. But here's a nice example of a Boingo hotspot. Maybe you've seen this at the airport. I don't think that they really intended to have a baseball, a thumbs up icon, and a lipstick in the bottom right there. But you can kind of tell what happened, right? The timeout was hit, the unstyled text is shown, and the fallback glyphs may not be what you intended. GitHub is another very egregious user of font icons. And I've had many discussions about that with them. And you can kind of tell what browser this Reginald is using here by the fallback glyphs that get shown. So this is not what GitHub actually wanted to be rendered here. Those are the default glyphs associated with Firefox characters in Unicode. Another great example I love is from Laura Hogan of Etsy. It's the same problem, right? So they've loaded icons for the first 4 stars. The half-star icon had a fallback to a horse for some reason. And they got this feedback. Why is there a horse emoji covering up the 5th star of my reviews? Well, it's because it wasn't a full star, it was a half star. But yeah, it's not good. But there are a bunch of other accessibility problems with font icons, right? So depending on what glyphs you've mapped your icon fonts to, they could be read by screen readers as something you may not have intended at all. And again, Vitaly and Chris kind of talked about this yesterday with Unicode Fallbacks. So the triple equals sign, which you might, I don't know, there's a ton of presentations within the last couple of days about hamburger icons. That's actually read in screen readers as identical to, because it's a mathematical operator. Oh. Black star or star. There's a heart suit, which probably is not favorite, if you're using that as favorite. So yeah, there's a lot of problems with that. So font loading is already complicated enough that we shouldn't have to add another layer of complexity onto font icons. Just use SVG for your icons. You'll be much happier. But really, the solution that we're trying to nail down here, we're trying to drive home, is that we want to embrace more unstyled text. The faster we can display unstyled text to our users, the happier they will be. At a bare minimum, you need to add a timeout so that your font requests are not single points of failure. And even better, in my opinion, embrace full unstyled text. Show the unstyled text from 0 seconds on. So a great thing that's kind of in specification land right now is the font display CSS descriptor. It's a great option. It's kind of the holy grail of font loading because it puts our solution right next to our font face block. It's right in CSS. We want a full CSS solution for this. And if you use font display swap, that will actually emulate the Internet Explorer behavior in browsers that support this font display descriptor. Sorry to burst your bubble, no browsers support this font display descriptor. But the other interesting behavior that is sort of in the specification that I think is really, really kind of cool is that there's a font display fallback. So that means there's 100 milliseconds maximum invisible text, which kind of tries to play to whether or not the font is already available to you in cache. So if that font is already available in your cache. But if the web font comes back after 3 seconds, there's a 3-second max, it will just throw it away. It will ignore it. It won't repaint with the new web font. Font display optional is even more sort of aggressive in this way. It gives you 100 milliseconds maximum invisible text. But if it doesn't make that 100 millisecond time frame, it just uses the fallback. So I'm kind of seeing this trend of more and more people saying, if it's not in cache, I don't want the web font. And that's a perfectly valid performance consideration to make. Personally, I like web fonts. I think fonts a good typeface is a really good use of your performance budget. So the CSS option, the CSS only option doesn't really work for us, but we can use the CSS Font Loading API, which is actually a JavaScript API, which is a very strange name for that, but whatever. And there are polyfills that exist for that, but I'm going to go through the native syntax just to make this presentation last longer, because polyfills, we won't use them forever. So this is what it kind of looks like when we want to use the CSS Font Loading API. This is how we fix the web font problem. We trigger a download programmatically. We say, hey, I want to load my Railway web font. And then when that font has successfully loaded, we have a nice function that executes. So it's very similar to the anti-pattern that we kind of talked about before, but we're adding a class here to the document, but that class is only applied after the font has successfully loaded. So here's what the CSS might look for that. Very similar, very straightforward. So this is what it looks like without the CSS font loading solution. We repaint at the beginning, usually with invisible text, when the font request triggers. And then we have this invisible text danger zone here that we want to kind of avoid. So what the CSS font loading API allows us to do is we know when the font has loaded successfully. We know the font has returned. It's different than Modernizer. Modernizer check will only check to make sure that font face is supported in general. This is, we know specifically the font face that we have requested has downloaded to our page because we've forced that and our callback is triggered. But if we use multiple web fonts on our page, as we had in the Slate example, that's not going to solve that problem, right? Because we have that weird race condition where we have 2 fonts available on our page. We have 2 repaints because each one of those fonts has its own timer associated with it. So if one font loads before the other, then we still have this partial text hidden on our headline. So what can we do to work around the Mitt Romney web font problem? I'll give him full credit for that. we want to group our repaints into a single repaint for all of our font files. So here's what the syntax looks like for that. The callback at the top is very similar to what we had before, but we've actually loaded two separate fonts and stuffed them into a promise. So the promise.all kind of says, when these two things complete, trigger that callback. So instead of this, we move to a single repaint at the end, which completely eliminates that race condition. And fallbacks are very important, right? Because we're relying so much now on unstyled text, fallbacks are much more important than they were before. And Joe kind of touched on this yesterday. He said people are willing to pay to eliminate advertising. So people are using content blockers to eliminate advertising on their page, but I would also say people are willing to pay for enhanced performance, not just to eliminate advertising. But the interesting thing about content blockers is that they often have a specific line item in them to block web fonts. So this is obviously a very prevalent problem in users' minds. Now I have this site that I developed called fontfamily.io, just a simple compatibility table for different default fonts installed on different devices and operating systems. If you want a good laugh, you can go out and check out Font Family Fantasy, which is a default CSS keyword. The browser support for that is all over the board. It's kind of, yeah, it's crazy. But when we have that reflow or that repaint between the unstyled text to our web font, we want to minimize the impact of that. We want to make that as smooth a transition as possible. And we can adjust our font family, our fallback font family, to do that. We can adjust the font size to do that. We can use font size adjust, which actually allows us to modify the X height of a font, which is the lowercase values. And then also line height. And there's a great bookmarklet out there called Fallback. So this is what it looks like when you trigger that. It gives you a nice little GUI on the right that allows you to put in your own font that you want to use. So for instance, maybe a web font that you want to load, and it will overlay that on top of your existing content. So you can sort of minimize the impact or adjust your properties to minimize the amount of reflow that happens on your content. I don't recommend using Comic Sans. So we want to ease that transition from fallback to web font, because the default browser behavior for font loading is so harmful to content on the web. So one of the things you should do is take the road less traveled, right? And if you get it absolutely right, your website won't need any roads. So use a font loading strategy. Don't accept the defaults.
Thank you.
Thank you.
Well done, sir.
Oh,
so
thank you.
would you like to join me?
Yeah.
No. All right. So web fonts. This is something we've been all thinking so much about over the last 2 years.
Yeah,
It's been so painful, isn't it?
Well, I keep waiting for them to fix it so I don't have to do conference talks, but
So in the end, it's all about the question, will Safari at some point introduce timeout or not? And of course, how much time we will have to wait until we have a more or less cross-browser support for the font loading.
yeah, I think they realize that it's
but
a
it's
problem.
kind of getting somewhere, yeah.
Yeah. So I'm hoping that they'll eventually either implement font display or add a timeout, because that no timeout behavior is just it's so bad.
Right.
It's really, really bad.
It's kind of annoying, yeah. So when you start a new project, what will be your strategy? So you have two options, right? You either have access to web fonts, so you can load them via your own server, or even, if you want to put them in local storage and so on and so forth. But sometimes you don't have access to the fonts because they're loaded via Google Fonts or Typekit or Font Deck. So how do you, in both situations, how do you make make sure that the content is delivered fast? How do you deal with fonts?
Right, that's really hard because third-party web font providers usually are not great in terms of performance. The JavaScript loaders are usually pretty heavy. They're pretty hefty. I won't name any names, obviously, but I will call out Google Web Fonts because their default one is they just say, well, just dump this link element into your page to load the font.
And it's blocking.
And
obviously.
yeah, that's the default browser behavior that we're trying to avoid. So yeah, I would say if you have to use a third-party web font, definitely go the JavaScript approach. But
So like with Web Font Loader or Web Font Face Observer, right?
Right. So the polyfills I mentioned are usually used with local fonts. So if you can host your own fonts, I would recommend to do that, just because the third-party ones are pretty bad.
Right.
So
Okay.
yeah.
All right. So how do we actually avoid this faux bold or faux italic from happening at all? So we don't even have this flash, because sometimes you end up going on a site and you see a fallback, right? Well, maybe after 3 seconds, or depending how they implement it, or right away. But then you can't really distinguish between bold and regular. Or maybe if you have a really keen eye, you can. But they look like it's a faux bold, right? How can we avoid it right away? How do we write CSS to make sure it never happens?
So that you never get
so I
repaint?
never get this. No, that I never get this faux bold or faux italic.
So you never get faux bold. Oh, well, I actually have an approach that I document on my blog. It's called the flash of faux text. So if you load your Roman typeface or your Roman font file and then the bold, the italic, and the bold italic variants, I do a 2-stage. So I'll load the Roman one first, and then I'll load the 3 other ones and sort of group that repaint together. So while the second stage is loading, while those 3 other font faces are loading, it will use that font synthesis behavior to sort of show you the ugly font synthesized versions until the web font is loaded. And I think that's okay if you want 4 different variants on your page. I think that's an okay method to use.
But what if you have, let's say, Arial, and you want just to have Arial italic, but you might be using, or maybe somebody's using the wrong font weight, like 600 or 500 for this, so it kind of shows up as bold, although it's really italic. Do you know what I mean?
Yeah, I mean, you have to adjust your font face blocks in that
exactly.
situation, yeah.
And in general, if you have a fallback, I find it quite difficult at times to actually adjust the metrics so the fallback actually matches the actual web font you have.
Yeah.
Because usually we tend to look into the platforms that people are using on the site, and then we will have a verbose CSS font stack, iOS platform, maybe Avenir or Avenir Next or something, and then Android, Roboto in that case, and then Microsoft something, which would usually be Segoy UI or Kendra and so on and so forth.
Yeah.
But they are very different. Like the typefaces, they're like the fonts.
They're different to you, but not to the users of those devices. You know what I mean?
Right, but then in that case, for example, if we have this big stack, right, we don't know if it's going to be Roboto that will be picked, if it's Android, but we need to adjust the line height, potentially.
Oh, I see what you mean.
For different platforms. And how, I mean, for that case, we will need JavaScript, right? To target specifically those devices.
You can use the CSS Font Loading Api to sort of tell when those fonts have loaded. There is a method in the API to let you just check without triggering a download.
All right, makes sense.
So you can use that to sort of adjust your metrics.
Okay. So this is easy for us to say, because like how to deal with fonts, because we're using Latin characters most of the time, and we don't worry too much about having too many glyphs.
Yeah.
What are we going to do with Asia? Japanese characters, because sometimes you end up with fonts, web fonts being 10 megabytes and more.
Yes. So that is out of my area of expertise.
Okay.
Yeah, I don't know a good solution for that. I mean, you will have to divide your fonts into separate files, and I think that Typekit does this very well, in that I think they have a mechanism to dynamically add deltas to a font file, which is kind of an interesting, crazy science thing that they have going on. But so they'll load the bulk of the normal characters that get used, and then they can programmatically add deltas into the font file.
Oh, that's interesting. So basically based on the content of the page, or?
Yeah, I think so,
That's interesting. I think they actually posted an article about it maybe 3 weeks ago. So that's...
they had a blog post about it, so you can check out.
Yeah, that's cool. And also, for example, you have web font providers like, well, we don't want to name names, but like Fondag, they just don't support WoW2 yet. They don't serve WoW2 at all.
Okay.
But Typekit, I think, does. Or maybe I'm not quite sure.
Yeah, I'm not sure about that either.
Because WoW2 is really, like, in terms of performance, in terms of compression, it's definitely better than WoW.
Yeah, it's great for performance, because one of the best things that you can do for your font loading is to minimize the time that it takes for that font to load. So yeah,
Right.
if you can have better compression, it's better.
Right. Another question is, how do we deal with web views? Very often you feel like when you're running a hybrid app, right, and you have a web view where you may be, I don't know, a tweet application, let's say, a Facebook application, you're showing an external website inside of that, web view.
Completely
right?
separate cache. And
Yeah. So do these caches talk to each other? So if you have a web font loaded, let's say,
Historically, they haven't. I think that might be changing with the newest version of some of these operating systems. But I think for the most part, they have completely separate caches. And so it's a huge problem with font loading because,
so
because you get
will
that
be
uncached version every
re-downloaded
time.
all the time, right?
Yeah.
So every single time you open up a tweet leading to the same site, this font will be downloaded, requested, downloaded, executed, and everything, applied. And then you close this tab, or maybe close this window, and then you come to the same site again, and you have the same story all over again.
That's why the font display optional and font display fallback are
Right.
really kind of interesting approaches.
Right.
Because they say if it's not in cache, do something like just use the fallback font.
Yeah, and this is why we have these conversations about delivering fallback right away, as fast as we can.
Yep.
Because otherwise it's just not going to work well.
Right. Yeah.
Right. Yeah, I think we don't have any more questions. I'm just generally curious, so when it comes to open type features, the support varies a lot.
Yeah.
And we had this article, I think, on one of the popular blogs, not sure which one it was though, about the optimized legibility.
Okay. Yeah. How it's very bad for performance. Yeah.
Is it still true? And what does it do, actually?
So I think that it's sort of the old way of opting into ligatures on fonts. So I think it's very bad for performance. But there's a
Still, right?
Yeah, I think so. Yeah. So you want to use. Oh gosh, I'm blanking on what the property is now.
Lig something. There is a shortcut.
It's font feature settings.
Font feature settings.
Yeah,
is
font
it?
feature settings. Maybe.
Yeah.
I don't know. Don't
So
tweet me on that.
That's okay. All right. And of course, the open type feature support really varies a lot.
Right. Yeah. That's
are
why
we getting somewhere there, or is it still a mystery land where everybody's doing their own thing?
I think it's getting better. And if you look at Bromstein's State of Web Type, he documents all of that on there. So it's certainly getting better
All right.
as time moves on.
So the future looks bright, and hopefully web fonts will be loaded fast.
If we get font display, yeah, it looks bright.
Yeah. Okay. Excellent. Thank you so much, Zach.
All right. Thank you.
Excellent. Great to have you here.